Hi guys, welcome back. We're going to be starting section 3 today. I kind of got cut off on the last slide, or the last section with just the last slide. So I'm just going to show that really quickly here, and you can see pretty much the comparison of proton to neutron to electron. Some of the big things to notice, the relative charges, electron and proton equal, proton positive, electron negative, neutron of course is neutral. The relative masses, you can see that the neutron is a little bit more massive than the proton. For all intents and purposes, they're pretty much the same, but the neutron is a little bit bigger, and then the electron is quite a bit smaller than either one. So just a couple things to kind of point out there before we start section 3. And of course there are particles smaller than protons, neutrons, but we're not really going to deal with those in this class. We'll save that for your quantum mechanics class in college or something like that. But some pretty cool stuff to look into if you get a chance. So section 3, we're going to do this in quite a few different parts. This is kind of the big section. Section 3 is going to get into how to tell the difference between different atoms, and we're going to establish some terms to sort of start off with. The first term is the atomic number. The atomic number is the whole number that we find on the periodic table. It's the number of protons in an atom, and it is the defining characteristic of that element. For example, if you look on a periodic table, oxygen's atomic number is 8. Anything with 8 protons is oxygen. That is what defines oxygen as oxygen, the atomic number. You can do whatever you want to with the number of neutrons, whatever you want to with the number of electrons, increase them, decrease them. As long as there's 8 protons, it's oxygen. It might be a different isotope or some kind of ion, but it would still be considered oxygen. For a neutral element, the number of protons is equal to the number of electrons. So what that means is that if we know the number of protons, we also know the number of electrons, as long as we are neutral. Now, if we're an ion, we can still figure out the number of electrons, but we may have to do a little addition or subtraction. And the reason that protons and electrons are equal to each other for an atom, for a neutral atom, is because they have to balance each other out. The mass number. The mass number is the total number of protons and neutrons in the nucleus of an atom. The total number of protons and neutrons in the nucleus of an atom. It is not the same thing as average atomic mass, and I'll say this again a couple more times. Mass number is the number of particles. It's a whole number. The number of particles in the nucleus. Number of protons, number of neutrons. That's what the mass number is. So if you want to figure out the number of neutrons, you take the number, the mass number, and subtract the atomic number. In other words, the number of protons and neutrons, and subtract the number of protons. And that's going to leave behind, of course, the number of neutrons. So again, atomic number, number of protons. Mass number, number of protons and neutrons. And the number of electrons is found pretty much from the number of protons. If we know the number of protons, we should also be able to find the number of electrons. Isotopes. Isotopes are atoms that have the same number of protons but different numbers of neutrons. And this is evident from isotopes like carbon-12, carbon-13, carbon-14. Again, it's carbon. So the atomic number of carbon is 6. So all of these are going to have 6 protons. 6 protons, 6 protons, 6 protons. The difference is when you find the number of neutrons. Now, because it has a mass number of 12, 12 minus 6 is 6 neutrons for carbon-12. 13 minus 6 is 7 neutrons for carbon-13. And 14 minus 6 is 8 neutrons for carbon-14. Same number of protons all the way across, right? All the way across. 6, but different numbers of neutrons. So what's the same? Number of protons. But what's different? Number of neutrons. And isotopes are very chemically similar to each other. They might have slight differences, but for the most part, they're going to be very chemically alike. They are useful for different things when you start to talk about like nuclear reactions. Certain isotopes are better for certain nuclear reactions, but we'll talk more about that when we get to the chapter on nuclear chemistry. Again, protons and electrons are most responsible for chemical behavior, primarily electrons. When we really talk about what's going on chemically, we're talking about electrons. Some different ways to express isotopes. You can have a written out the name of the element followed by the mass number, like gold 197 is an isotope of gold, which has a mass number of 197. And you can always find the atomic number by looking on the periodic table, which everyone should have one. I'll probably give you one. Sometimes you're also given the symbol, which has the mass number in superscript and the atomic number in subscript, or you're given just the symbol with the mass number. Again, in order to really know about the isotope, you need that mass number. Because again, that's going to tell you how many neutrons you have. The number of protons is easy to find. You just look it up on the periodic table. So let's try really quickly here. Let's do protons, neutrons, and electrons. And we are going to be using our periodic table. If you have one handy, just go ahead and pull it out. Silver 108. Because it is silver, I know that it is going to have a symbol of Ag, and silver has an atomic number of 47. And because this is a neutral element, it should also have 47 electrons to balance it out. The number of neutrons, I'm going to take 108, which is the mass number, minus the atomic number, which was 47, and that is going to leave me with 61 neutrons. Similarly, carbon 13, and this is nice because they just give us the atomic number down there, 6 protons, 6 electrons because it's neutral. And then they get neutrons, mass number, which is 13 in this case, minus the atomic number, which is 6, and we should get 7 neutrons. And lastly, the bromine 108. Bromine has a atomic number of 35. Oh, for a really high number there. 35. Ooh. So 35 electrons as well. And in order to get to the number of neutrons, we take the mass number, which is 108, subtract the atomic number, which is 35, and that should leave us with 73 neutrons. So as you can see, it's really easy to figure out protons, neutrons, and electrons. And if we were given a mix of data about the protons and the neutrons and the electrons, we could also figure out information about the isotope that we're talking about as well. All right, almost done with this particular section. Ions. Ions are atoms with a charge. They have lost or gained electrons. It says an electron, but electrons, because you can have a charge of more than just plus or minus 1. So they've lost or gained electrons. Positive ions have lost electrons, so they become less negative. And when you become less negative, you become more positive, right? If you are a negative ion, you have gained electrons. So you've picked up negative charge. For example, oxygen. Oxygen can form a -2 charged ion called oxide. And if we look at this, oxygen is still going to have protons equal to 8. All oxygen does. But the real question is how many electrons? Well, if this were neutral, oxygen would have 8 electrons, but it's not neutral. It has a -2 charge. So because it has a -2 charge, your normal 8 electrons has to have 2 more to give it the -2. So instead of 8 electrons, it's actually going to have 10, right? And that's where the -2 charge comes from. You have 2 more electrons than what you do protons. aluminum with a +3. The aluminum ion is going to have, aluminum has an atomic number of 13, so it's going to have 13 protons, and because it has a +3 charge, it means that it has 3 fewer electrons than what it should have, right? Because positive ions have lost electrons. So 13 minus 3 is going to be 10 electrons. You can see that aluminum with a +3 and oxide with a -2 both have the same number of electrons, 10, while having very different numbers of protons. So ions, pretty easy to handle. And I'm going to go ahead and stop there, and we'll do a separate video on average atomic mass and talk about it. Make sure if you have any questions, you're writing those down, and we'll answer those in class. Thanks for watching, and we'll see you soon. Bye.